Hi guys, let me welcome you all to another video. So in today's lesson, we're going to focus on analytical geometry. So it says in the diagram below, we are given 4 vertices. These are the vertices of quadrilateral PQRS. So we don't know what type of quadrilateral this is. So the first question says calculate the length of PQ. Leave your answer in third form. So we need to find the length of PQ. And we need to leave our answer in third form, meaning we should see a third. So to find the length of PQ, we need to use the distance formula. We can write PQ is equals to the square root of XQ minus XP squared plus YQ minus YP squared. So for our given equation, I've written XQ and YQ that correspond to 6 and 6 for Q, and XP and YP that correspond to 7 and 4 for P. This just makes substitution easier. So this is equals to the square root XQ is 6 minus XP 7 squared plus YQ is 6 minus YP 4 squared. So you can take the square root of that. 6 minus 7 is negative 1 squared plus 6 minus 4 is 2 squared. And this is equals to negative 1 squared is 1 plus 2 squared is 4. So this is equals to the square root of 5 units. So the next question says if T 7 over 2 and 7 over 2 is the midpoint of QS, determine the coordinates of S. So let's first establish where the line QS is. So QS is given by this line. And we're told that the midpoint T for QS is x coordinate 7 over 2 and y coordinate 7 over 2. So the x coordinate of T is literally the average of these two coordinates, and the y coordinate of T is the average of those two coordinates. So let's apply the midpoint formula. So we can say the midpoint of QS, which is equals to T, is equals to XS plus XQ over 2 YS plus YQ over 2. So now we can substitute. XS is T plus XQ is 6 over 2 and YS is K plus 6. YQ is 6 over 2. And this should all be equals to 7 over 2 and 7 over 2. Because we've learned that the midpoint of QS and T are the same. So it means their coordinates are equivalent. So we can just equate the x coordinates and the y coordinates respectively. So let's start with the x coordinates. We can say 7 over 2 is equals to T plus 6 over 2. So you can multiply throughout by 2. So 2 and 2 cancels. Therefore, 7 should be equals to T plus 6. Therefore, T should be equals to 1, which is the x coordinate of S. And the same can be done for the y coordinates. We can say 7 over 2 should be equals to K plus 6 over 2. Once again, you can multiply throughout by 2. So 2 and 2 cancel, 2 and 2 cancel. So 7 should be equals to K plus 6. Therefore, K should be equals to 1. And this is the y coordinate of S. So therefore, the coordinates of S is 1 and 1. Next question says if the coordinates of S are 1 and 1, show that PR is equals to QS. So what is this PR and what is this QS on our diagram? So QS we've seen is the diagonal for the given quadrilateral, and RP is the other diagonal. So we need to show that the length of SQ and the length of RP are equal. So we can write the distance formula for SQ. We can say SQ is equals to the square root of XQ plus XS squared. So distance SQ is equals to XQ minus XS squared plus YQ minus YS squared. So upon substitution, XQ for the given case is 6 minus XS is 1 squared plus YQ 6 minus YS is 1 squared. So this is equals to 6 minus 1 is 5 squared plus 6 minus 1 is 5 squared. So this is equals to square root of 25 plus 25, which is equals to the square root of 50. But 50 can be seen as 25 times 2, square root of 25 times 2, which is equals to 5 square root of 2. So now let's find distance RP. RP should be equals to the square root of XP minus XR squared plus YP minus YR squared. So now we can substitute yet again. XP in the given case is 7 minus 0 squared plus YP is 4 minus 3 squared. So this is equals to the square root. 7 minus 0 is 0. 7 minus 0 is 7, and 7 squared is 49, plus 4 minus 3 is 1, and 1 squared is 1. So this is equals to the square root of 50, which is equals to 5 root 2. So now we can say therefore PR is equals to QS. So the next question says we need to show that line QR is perpendicular to RS. So we need to show that this line QR is perpendicular to RS. For this condition to be true, for these two lines to be perpendicular, we need to show that the gradient of QR times the gradient of RS. When multiplying the gradients, we should get negative 1. So we need to prove this condition. MQR times MRS is equals to negative 1. Whenever we want to show that lines are perpendicular, we need to show that when multiplying their gradients, you get negative 1. So let's see if this condition holds true for the given case. So MQR, so let's prove this condition. So let's start with the left hand side. Is equals to MQR is YR minus YQ over XR minus XQ. And for the gradient of RS, it's YS minus YR XS minus XR. So YR is equals to 3 minus YQ, which is 6, all over XR is 0 minus 6 times ys is 1 minus 3, yr is 3, all over xs is 1 minus 0. So 3 minus 6 is negative 3, 0 minus 6 is negative 6, multiplied by 1 minus 3 is negative 2, 1 minus 0 is 1, so negative and negative cancels. 3 goes into itself once and into there twice, so it's 1 over 2 multiplied by negative 2, so this gives us negative 1, which is equals to the right hand side. So we've just proven this condition, and now we can say therefore QR is perpendicular to RS. So the next question says, hence, what type of special quadrilateral is PQRS? Motivate your answer. So we can say PQRS is a rectangle, and the reasons are the diagonals are equal in length. We know for a rectangle the diagonals are equal in length, and we've shown this in 1.3. And the second condition is the interior opposite angles are 90 degrees, as we have shown in 1.4. Because these two lines are perpendicular, it means the angle that forms between them is 90 degrees. Therefore, PQRS qualifies to be a rectangle. And the last question says, calculate the size of RSQ, angle RSQ. So let's identify angle RSQ on the diagram. So on the diagram, angle RSQ is given by this angle, RSQ. So this here is the angle that we need to find. We know that triangle RSQ is a right triangle. So let's see how we can use trigonometry to find the missing angle. So the diagonal in this given case qualifies to be the hypotenuse, and we found its length to be 5 root 2. So let's note it, 5 root 2. We also have distance PQ to be root 5, and we know opposite sides for a rectangle are equal. So if this is root 5 here, it means this is also root 5. And with respect to this angle, this qualifies to be the adjacent side, and this is the hypotenuse. And if we use SOHCAHTOA, we know that the cosine of the given angle RSQ is equals to adjacent over the hypotenuse. And the adjacent is root 5, hypotenuse is 5 root 2. So therefore, angle RSQ should be the arc cos of, which is root 5 over 5 root 2. And this is equals to 71.57 degrees, correct to 2 decimal places. Thanks for tuning in. See you in the next one.